Hello, thank you for joining us today for the ArcGIS Field Maps Enabling Asset Collection Workflows session. My name is Kevin Burke, and joining us today is Colin Lawrence, and we are both product engineers on the Field Apps team. So today we're going to be going through an introduction to ArcGIS Field Maps. We're going to be discussing methods for performing an asset collection. We're going to be capturing assets using high accuracy GNSS receivers. And lastly, we're going to share some additional resources with you. So throughout the years, we have developed our digital field operations capabilities to location enable all phases of fieldwork. Our solutions are built to support the key activities that organizations engage in, such as planning, which involves creating, assigning, and being able to see the status of fieldwork across your teams. Navigating, helping your mobile workers get to the job site even in remote locations with unreliable service or via custom and private road networks. Providing greater understanding and situational awareness by making your maps and all of your GIS data available to your workers out in the field. Digitally capturing and updating information about your assets in their environment, replacing paper-based methods and streamlining your processes. Monitoring the location of your employees to improve team coordination and response times. And lastly, being able to collaborate and coordinate with your teams both in the field and in the office, ensuring that everyone is on the same page and moving in the same direction. As you can see here, there are 5 apps that we are planning to bring into the Field Maps app. ArcGIS Workforce, Collector, Explorer, Tracker, and Navigator. Now this will be accomplished throughout a phased approach. Our first release of Field Maps effectively combined the capabilities of Collector, Explorer, and Tracker. Field Maps has been built with the Collector codebase and with a careful eye for design so that those who have been using Collector or Explorer will experience a sense of familiarity and a low learning curve as they transition to working with Field Maps. In subsequent phases, we will look at bringing the functionality in Workforce and Navigator into the app as well. So Field Maps has 2 components. The Field Maps web application on the left, which is where you prepare maps for the field, and the Field Maps mobile application on the right, which is where you do the work in the field. And the mobile application is compatible within both the Google Play and Apple App Stores. So the Field Maps web application is where you configure your map properties, configure content for layers and tables, manage feature templates, enable and manage offline settings, create smart forms for data collection in the mobile app, as well as share and deploy maps to the Field Maps mobile app. And there's more to come. The Field Maps mobile application combines the best-in-breed mapping system with a world-class data collection solution and a revolutionary location tracking technology through the combination of Explorer, Collector, and Tracker that have already been included in the initial release. Functionality from Workforce and Navigator will be implemented in subsequent releases. The next section we're going to be discussing is called Methods for Asset Collection. So what are some types of supported data within Field Maps? You can use feature services that are hosted in ArcGIS Online, ArcGIS Enterprise 10.5 and newer, Portal for ArcGIS 10.4.1 or earlier, or ArcGIS Server. You can also work with versioned datasets using either traditional or branch versioning, and you can also edit related tables. Within the context of these demonstrations, we're going to be using ArcGIS Online hosted feature services. So now let's jump into a demo for configuring data for asset collection. So leave the presentation, and what we're going to do is we're going to go ahead and go into our browser. So we have an existing web map that we've created called Park Assets that has a point layer called Amenities. It's blank, there's no existing features on it right now, and if we choose our Amenities layer, if we go to, we can see that we have different types of amenities with different symbols that we can capture into the field. Right? We also have a pop-up that we've already configured for this data. And what we're ultimately going to be doing is we're going to be further configuring this map using the Field Maps web application. So let's go ahead and go over into the item details for that same web map that I just showed you. And let's go ahead and open up the Field Maps web application, which is accessible through the app launcher. So here we go. So Field Maps. And you can see we have our park assets map available. We're going to select it so that we can further configure it. Right off the bat in the overview page here, there's a lot of information that you can already see. In this case, I don't have a summary. This map is supported for offline, so it's offline enabled, and I have not shared this map. So any of these settings I can change in Field Maps in the web application. I'm going to leave them as is for now, and where I'm interested in is over here on the left side under Content. I'm going to choose under Editable Layers my Amenities layer, and at the top you have two different tabs. Now the tab that you're currently on allows you to see the templates you have. You can even set defaults for individual templates. But in this case, we're interested in the form section specifically. We want to configure a smart form for this amenities layer. There's two ways, right off the bat, you can see there's two different ways you can configure a form. You can just simply see all the available attributes over here on the right side. You can drag them over here into what's called the canvas. You can drag them over into here. Or you can choose Convert Pop-Up, which is what I'm going to do since it's kind of the quickest and fastest way to get all your fields into the canvas without manually dragging them over. And it adds them all into a group, right? These don't have to be in a group. I can drag these outside of this group. I'm going to leave them in the group for my data collection, but I want to change the values that this group has. So what we're going to do is we're going to make a few changes here. So over here on the right, so I've selected the group, and you can see we have our properties. We're going to give this a group name. That's different than group 1. And we're going to leave this as an expanded group. So right when you start editing, you're going to see all the attributes listed. You don't have to expand the group. Now we're going to go down to a field. We're going to choose Asset ID. We're going to make this a required field. And we're going to add some hint text into this field so that we can alert the field worker on exactly what type of formatting we're looking for this particular asset. We're going to go down to type of amenity. We're going to leave that one as is. For park name, we're going to make this required. Same for capture date. We're going to toggle on required. For field worker, we're going to also make it required, but we're going to add some additional hint text here as well so that we know exactly the type of name formatting that we're looking for. So photo captured is also going to be required. And now for needs maintenance is also going to be required. Now what we're going to do is we're going to deselect needs maintenance, and we're going to return over here. We have this form elements under this form builder section on the right hand side. We're going to drag in another group. We're going to add it to the very bottom, right? Then we're going to add in the fields from the previous group. We're going to drag notes and action needed into this new group. We're going to give this new group a better name. We're going to call it maintenance notes. We're also going to give this group a description. So let's go ahead and grab our description. But we're also going to make this a collapsed group, so this is not going to be expanded by default. What we're also going to do is we're going to add a expression, a conditional visibility expression to this particular group. So we only want this group to be displayed when certain criteria have been met. So we're going to go ahead and, for this new expression, we're going to give it a name. We're going to go ahead and populate with an expression. Now in this case, we're interested in the maintenance required value. If it's yes, then we want this group with the fields to display. If it's no, then we want it to remain hidden. So we're going to choose OK. And lastly, what we're going to do, and you can see we have in the group next to the group name, we have the icon denoting conditional visibility. You can also create conditional visibility for individual fields. In this case, we're not, but you could. Lastly, what we're going to do is for this action needed, we're going to choose required because we want this information to be populated when it's visible. So now we have our form, and you can see it's pretty much ready to go. So we just need to save it so that it updates our web map with this new form information. So at this point, we're ready to go to start our field data collection. So let's go ahead and go back into our presentation, and let's continue. So a few things I wanted to point out that we didn't necessarily cover in the demonstration is you do have the ability for the feature services themselves to configure how features are collected. You can do that through the feature service edit capabilities, which is accessible through the item details page for the settings of that particular feature service. And you can control whether or not that service supports updating, adding, deleting, update attributes only. You can toggle on different combinations of those edit capabilities. You can also create what are called feature layer views, which are essentially new services that reference the original source feature service. And with those new services, you can configure different edit capabilities. You can set different type of view, what are called view definitions, to see what type of features themselves are visible. And you can create multiple of those. So if you want to symbolize the same features in multiple different ways, you can do that with unique view layers. You can also enable editor tracking so that you can keep track of who created and last updated these features. And lastly, you can control who has access to viewing and editing features through ownership-based access controls. So depending on a username, right, they may only be able to see and edit the features that they own versus everybody else's. So you can toggle those settings on or off through the settings of the feature service in the item details page. We also looked at Field Maps, the Field Maps web application, for configuring web maps. So in general, you can use Field Maps Web to configure smart forms for layers and tables that include grouping, required fields, conditional visibility, etc. Things that we built together in the demonstration we just did. You can also specify default values for editing templates. You can generate offline map areas. You can share maps with groups, and much more. And this app is available in ArcGIS Online and ArcGIS Enterprise 10.8.1 and newer. So now we're going to do a demo where we're going to be capturing point assets using the Park Assets inventory map that we constructed and configured earlier on. So let's see how that works. So here I am at a local park, and I'm using my current GPS location where I'm going to be capturing several point features. So here I am walking up to the first point feature, and I want to highlight the GPS tool in the upper right corner, the little triangle icon. You can determine that it's currently tracking my location when it's filled in. When the tool is hollow, that means it's no longer tracking your location, and if you were to create a point, it would be a manual point location, not a GPS point. So we're going to be using the GPS location to capture these points. So I'm going to capture a water fountain feature. We're going to take a photo of this feature. Okay, and now we're going to utilize the form that we constructed through the Field Maps web application. So if we choose the asset ID, you can see there's the hint text that we created earlier. So we're going to go ahead and fill in the name of this asset ID with a similar naming convention. We're going to choose the park name that I'm currently at, Central Park. Now we're going to choose the current date where I captured this feature. For field worker, you can see there's the hint text, first name, last initial. I'm going to go ahead and follow that convention and enter in my name. For the photo captured, you're going to say yes. And again, these are all required fields that we defined in the smart form. For maintenance required, we're going to choose yes. And you can see that the group that was hidden before is now become visible with the attributes that we need to populate. In this case, paint is needed for this fountain because the paint is faded and looks to be chipped and it needs to be replaced. Okay, let's go ahead and submit this feature. Okay, now we're going to move on to capturing our next park asset. In this case, we're going to be capturing a light pole. So we dropped our light pole feature. We're going to take a picture of the base of the light pole. And we're going to proceed to fill out our form in a similar manner as we did with the water fountain. So we're going to call this one a light pole. Same park name, but you'll see now at the top we have this recent section because we just used Central Park in the last feature we created. So we can easily find it at the top of the list rather than having to search for it. Now in here we can type in our first name, last initial like we did before for the field worker. Or we can use the recent values that you see at the middle of the screen, which will store that information for that field. There's several values that you can store within a recent values list. so you don't have to actually retype it in every time. So the photo captured yes, and this does not need maintenance, so we can proceed to submit it. So there we capture the feature in a similar way that we captured with the water fountain. But now we're going to move on to our next feature, which also is a light pole, but we're going to capture it in a slightly different way. So I've identified that last feature because I simply want to copy it. So in the bottom left corner, you see there's a tool, and it's the copy tool. We're going to tap that, and it simply creates a new feature at my current location, but pulls over the attributes from the previous feature. And we're going to simply make incremental changes like the light pole ID, the asset ID, and we're going to take a new photo because it will not bring over photos from the last feature, obviously, because they're no longer relevant for the new feature. And we're going to simply submit that. So it's much faster because most of the other attributes remain the same for this feature. So we don't need to recreate them. Now we're going to move on to our third feature. Again, it's also a light pole. And you can see how the map auto pans to keep up with me because I have auto pan mode enabled. So now we're going to copy from the last pole, and we're going to change the light ID to 3. We're going to take a new attachment. And we're going to simply submit that. So now we're going to move on to capture a different feature. Say there's a feature that's quite a distance away from your current location, and you're obstructed to getting to it. You can't get to that feature. So you can place it manually. In this case, I'm going to drop a pin at this location, right, which happens to be a certain distance away from me that I can't physically get to. But I can see it on the map, and I can try and place it as close as I can manually by dropping a pin. By simply long pressing on the screen, and you can drop a pin, and you can see that magnifying window show up. Now you'll see there's an option here on the bottom called Collect Here. We're going to use that option to drop a new feature at that pin location. And this happens to be a bike rack. So we're going to drop that feature there. And we're going to proceed to fill out the attributes just like we did. One other thing I wanted to also mention in this display here, I'm going to stop the video for a second, is in the upper right corner, you see that we have the GPS tool. It's no longer filled in but hollow. This indicates that auto pan mode is no longer enabled and your location is not going to be tracked. So if you were to create a feature, it would be referred to as a manual location, not a GPS location. So you would simply tap on that tool to then center back on your current location. So now let's go ahead and proceed to fill out our form. So we have our asset ID, and this is going to be a bike rack. Park name, we're going to choose it from our recent list at the very top. Choose today's date. Field worker, once again, from our recent values list. And the photo captured, we're going to choose yes. Needs maintenance. And say yes, and it needs to be replaced. And now that I filled out all my required fields, the submit button becomes active, and I can go ahead and submit just like you saw in the previous features. So in this demonstration, we covered quite a bit of ground with what we could actually capture. So we captured using our GPS location. We then used the copy tool to copy attributes between multiple features to speed up that collection. And then we also used the Collect Here functionality through a pin being dropped on the map to place a point manually at a distance away from me. So we covered a lot of ground with being able to capture different methods of assets in the field. So the next area that I want to discuss is scanning QR and barcodes into a field to capture attributes. So let's see how that process works. So here we have a gas utility network map that I've already downloaded onto my device. And here we are, we're looking at a few service lines that we want to choose one to scan a barcode for. So we're going to choose our service line. And you can see we have our pop-up information and we have a component detail section with a bunch of unknown information. So after we scan our barcode, that information will be populated. So we're going to edit that service line We're going to go down to our particular field, and it's called barcode, in this case barcode. You can see in the upper left corner we have a barcode tool. We're going to scan our barcode. We're going to choose done. There's the barcode value. We're going to go ahead and choose submit. Now once submit is completed, there's also an arcade expression in this particular map that extracts certain information from that barcode. Information such as manufacturer, production date, material, etc. That information is no longer unknown. Now that is one step further. It's not required for scanning barcodes. I do have a link to a blog article that explains and provides the exact arcade expression that I used here. If you're interested in going further than simply just capturing the barcode value, if you want to extract certain information from it, this blog will explain how that process works. So now I want to turn it over to Colin, who's going to share more information and methods for collecting assets in the field.
Thank you, Kevin. Now that Kevin has shared some basics of collection in the field using point features and smart forms, I want to dive into line and polygon collection. So I'm going to go straight into a demo for you guys. For this demo, I'm going to be using an iOS device in dark mode. I will be showing you guys some streaming and snapping functionality. Let's first check what we can configure in the settings. If we tap on the settings, we'll notice there is a section called Collection. This section holds the settings that are related to your collection workflows. Tapping on that will display a submenu. Here, let's focus on the streaming and the snapping options. When you tap on streaming, you have another menu to configure either time or distance. We're going to leave this on distance for now. I am going to change the distance down to 5 feet from the default of 10. Your snapping may be on by default. Currently mine is off, so let's turn that on. Now that we have configured our settings, let's jump into our map. I'm going to continue a park asset inventory, similar to what Kevin demoed earlier. However, we're going to be focusing on lines and polygons. I have arrived at a local park, and I am tasked to collect a new pathway feature. As I am using the integrated receiver on my iPhone device, I'm waiting a bit to make sure I get within the required accuracy. I'm going to start a collection and select a new path. You are now ready to start streaming. However, in the time that has passed between selecting your feature and now, your location may have moved a little bit. You can use the overflow menu to update to your current GPS location. And then, again from the same menu, start streaming. You notice when you start streaming, the GPS banner now indicates that you are streaming. As you move, a breadcrumb of points is dropped behind your current location. From the overflow menu, you can change the streaming interval, similar to what we saw in the settings. I'm going to set this to 15 feet because I believe 5 is a little bit of overkill for this. You'll notice now that I've changed it, the points are starting to be a little bit more spaced out. Although I am using distance, you can also set a streaming interval using time. While you are streaming, you are still able to update the assets as you go. I'm going to set the field worker to myself, and I can note that this is a little bumpy and requires maintenance. You can also stream while the app is not in the foreground. I have minimized the app, and I will continue walking for a few seconds and show you that the app is still collecting vertices in the background. You see when I open the map back up that points have been collected while it was minimized. You can also take photos or add attachments while you're streaming, but I do not show that in this demo, for fear of tripping and falling. Another thing to look out for is your GPS accuracy. If it does fall out of your required range, streaming will temporarily pause. I've reached my final destination. I just want to show you that you can still manually place points after you have stopped streaming to add to the line. You can also use undo if you place a point incorrectly. Let's go ahead and submit this. Now that we have submitted, we can confirm that the attributes that we updated while streaming have been populated in the feature. I did forget to add the park name, so let's add that now and resubmit. Now that we have used streaming to create a new path alongside this park, let's update the polygon for the park so that it is in line with the path. To do this, we're going to use snapping. I'm going to select the existing polygon and start editing. We need to select the nearest vertex to where we want to update. You'll see the vertex is now highlighted. And you see when I hover over the path line, an orange indicator shows up. We then use the overflow menu to update the selected point to that location. I'll do this a few times, for example. You'll notice that the next vertex is automatically selected in a clockwise rotation. You can see how snapping would be very useful whether you're working with linear or a meandering feature like a path. Once we submit, we see that the polygon has been updated to roughly follow the path. I could have taken some additional time to place additional vertices along the path to get this as an exact match, but given the low-grade accuracy of the integrated receiver and for demo purposes, I sped this up a little bit. Now let's take some time to review the asset collection workflows that I went over in our previous demo. One of the topics I covered was snapping, which is useful for when you want to snap features to existing assets. You use part or all of an existing asset location in reference to your new feature that you're collecting. You can toggle it on or off under the collection settings, and if you're having trouble getting snapping to work, just make sure you're zoomed in far enough, as there is a 1 to 10,000 scale requirement. We also covered streaming. Streaming is where you collect a line or a polygon asset which follows your GPS location as you move. This helps you create smooth sections along your line or polygon features. You can set it to drop vertices based on the distance you're covering or the time elapsed. You can also update the attributes in the pop-up while you are streaming. And it can be very useful at times to stream in the background if you need to put your device in your pocket, for example. Next, I would like to pivot a bit and talk about some additional methods for asset collection that can be utilized. You can use the Universal App Scheme or app integration to enhance field collection workflows and increase productivity. For example, you can share a link directly to your map through an email, text message, etc. You can even start the data process right away, right when the map opens, and pass additional attributes. And with that short introduction, I'm going to jump in right away and show you guys how this works. For my demo, I'll be showing how a few different URL parameters work and how they can really jumpstart your workflows in Field Maps. I will be using QR codes to distribute these links, but this is not the only method. I will cover others later in the slides. The first one I'm going to use is going to be to start tracking. When I scan the URL, you'll notice I'll get a notification to open Field Maps. When Field Maps is opened, I get a notification to start tracking. Once I tap OK, tracking has started. I can confirm from the GPS banner and the GPS details that tracking is running. With this URL, I have also set a tracking duration, so that tracking expires in 5 days from now. Now let's scan another code. The next code will be used to open a specific map and center on a bookmark. You'll notice that a different map opens and centers on Zion National Park. For proof of concept, let's use the bookmark tool and zoom to the default map extent. And zoom back to our Zion bookmark that we passed in the URL, showing that it is the same extent. Now let's scan another QR code. This next one will be to add a line feature to the parks map that we used previously and pass some attributes. you'll notice that when Field Maps opens, it opens to the template picker for the line feature class. We can select a type of path, and a point will be dropped. You will notice in the feature pop-up that we have also passed an asset ID along in the URL. You can submit the feature and confirm that the asset ID was passed. The next URL we will try will be to add a polygon feature, pass attributes, and also pass geometry for that feature. You'll notice that the template picker for the park areas shows up first. Once we select an area, the geometry that was passed is automatically dropped. We can confirm that this is the correct location and also that the asset ID has been passed in this case as well. Make any other changes that are necessary to the pop-up, and then we can submit. The last QR code I'm going to show you is the update a point feature. Let's first check the attributes here. You'll notice that the action needed and field worker are blank. We are going to pass these. So let's go scan our QR code. You see that the map opens back up, selects this feature, and we see that the field worker and action needed fields are now populated. We can make any other changes we need and then submit the feature. Now let's recap some of what we covered about app integration and go into some more details. App integration can be used to accomplish multi-app workflows for when field activity is not limited to a single task. Some of the methods to call field maps could be if you're using a Esri123 form and tapping on a URL to open field maps, using a QR code like I did in my demo, linking out from a web page, linking out from an email, a third-party app, etc. There are many ways that you can accomplish this workflow. I should note that Field Maps uses the Universal App Schema. This is indicated by the HTTPS in the URL. So a URL might look like https://fieldmaps.arcgis.app, followed by the parameters and values. This is different from the custom URL scheme that was used in previous apps. This has been deprecated. Those look like ArcGIS-appname. URLs using that format with field maps won't open the app. So what can you accomplish with the URL? I covered a lot of these things in the demo. First, you can just simply open field maps. You can also sign into a specific portal. You can open a public-facing map using the anonymous access parameter. You can open a map, center and scale, open a map, perform a search, open a map and add a new feature, or open a map and update an existing feature. With the adding and update, you can also pass additional attributes to those features. And I also showed how you can toggle tracking on and off using a URL, if your account is licensed for tracking. For more information on how to build a Field Maps URL using the Universal App Scheme, see the link to our documentation on this slide. I also provided a QR code. Another method of app integration is the relationship between Workforce and Field Maps. I didn't demo this. There are some additional details you can see by following the link in this slide or by using the QR code to link out to the documentation. But basically, what you do is you configure a project in Workforce Web, and you can integrate this project with Field Maps. You'll select the web map that you want to open in Field Maps, specify either the entire Workforce project or specific assignments to integrate, and pass the Workforce Assignment ID field into a feature layer within Field Maps. What this looks like within the Workforce app, when a field worker arrives at an assignment, they can optionally choose to collect an assignment. Once they tap this, they can open Field Maps, and that assignment ID is automatically passed to the new feature. Now that we have covered a lot of the basics of asset collection using the integrated GPS receiver, we would like to talk about the high accuracy workflows you can accomplish in field maps. You can use high accuracy receivers in conjunction with field maps to capture accurate and precise locations. The setup process can vary between receivers, but is generally easy to set up and get started. I will show you an example of the setup process in a demo shortly. There are two sections within the app settings to focus on. The first is the location provider, where you add and connect to your receiver. And the second is the location profile, which may be necessary if you are utilizing a correction service that introduces a datum transformation. We do support a wide range of consumer and survey grade receivers to meet organizational data accuracy requirements. You can achieve efficient processing on the fly using a correction service like Ntrip or a satellite-based correction. And you can also gain confidence in the data collected using GPS metadata, which we will discuss in more detail later on. Now let's jump into a demo of the GPS receiver setup process. In this demo, we will be using an iOS device and connecting to a Trimble R2 receiver. The first step is to connect to the receiver via Bluetooth. Once you are connected, we're going to open the Trimble Mobile Manager app. And select the receiver as the position source. And connect. Once connected to the position source, we want to toggle this off, as this connection will interfere with connecting in field maps. We are then going to go into the configuration screen to set up our Ntrip connection. We're going to set up a custom local. Protocol is Ntrip, and enter our server URL to connect to our local base station. Once we have entered the URL and port, we can select the mount point to connect to. Now that we have configured the server parameters, we can move on to the GNSS output section. For detection mode, we will select same as source because we have configured a custom local correction source, and the output reference frame and source reference frame are the same. For geoid, we will select something more relevant to our location. We are selecting geoid 18, which is intended for use with coordinates in the NAD 83 2011 datum that we are using in this workflow. Now that we have finished configuration in Trimble Mobile Manager, we will open up Field Maps. From the home screen, we will select the settings in the top left-hand corner. You'll notice the location section. Let's start with the location provider to connect to our receiver. From this screen, you can tap Add in the top right-hand corner, and your connected receiver should populate here. Once you've selected it, we can define an antenna height if necessary. And once added, make sure you tap your receiver to connect to it. With Trimble, we may need to connect to Trimble Mobile Manager. Use the Browse button to browse to the Trimble Mobile Manager folder and make the connection. Once that is done, tap Open, which will perform a handshake between the two apps, and then you will be connected to your receiver. We'll next set up a location profile. Tap Add on the location profile screen, and you will first define the coordinate system of your GNSS receiver. As I mentioned before, ours is NAD 1983 2011. Then define the coordinate system of your map. We are using an Esri base map, so we are defining Web Mercator auxiliary sphere. Then define your collection area. You can use the GPS tool to zoom to your current location. Once that is selected, select the most relevant datum transformation for your location. Keep in mind these are ordered by accuracy. Once you select the transformation, give your profile a unique name. And make sure it is selected. Once you are connected to your receiver, there are a few other collection-specific settings that you may want to set. The first is accuracy. There may be a required accuracy by your project or your organization. The default is 10 meters, but let's bump this down to 10 centimeters. Keep in mind there is also a setting to turn on the 95% confidence interval. You can also toggle on GPS averaging from this menu. This will allow you to collect multiple points to get an average location. Now that we are set up, we are ready to go out into the field. But first, let's recap some of what was covered in that demo. We talked about how you use the location provider to connect to your GPS receiver. This is located within the app settings. There is support for integrated receivers and Bluetooth receivers. This is where you will connect to a named receiver, and this is also where you specify the antenna height, if it's relevant to your receiver. We also discussed how you configure your location profile, which is the data transformation that you will apply between your GPS receiver, correction service, and your web map spatial reference defined by the base map. Afterwards, we showed the datum transformation screen, which is filtered by your map extent and the accuracy of the transformation. From this screen, you can also download a grid-based transformation. We also showed how you can define a name for your profile, as you may have multiple when you are working with different areas, with different correction services, different maps, with different base maps, etc. Keep in mind that you also want to minimize the use of a datum transformation if possible. And we also discussed location accuracy and the 95% confidence interval. We discussed setting up a required accuracy value based on the project and organization requirements. We also discussed how you can change the accuracy units. In our case, we changed from meters to centimeters, but if you set your profile to use imperial, you can use feet and inches as well. We briefly mentioned the 95% confidence interval. This is a setting which is required by some organizations. You would toggle it on to report accuracies at 95% instead of the default RMS accuracy, which reports accuracy at around 68% confidence. I will now turn it over to Kevin, who's going to go through a high accuracy asset collection workflow in his demo.
Thank you, Colin. So now we're going to see a demo on actually utilizing that receiver configuration to capture assets in the field. So let's see how that works. So here we are, just to reconfirm, we have our same provider. We're using a Trimble R2. We have our location profile, which is what we set up before at the RTK, and you can see we have our accuracy set to 10 centimeters. So now let's go ahead and go into our water utilities map. And here we are, we're displaying our GPS details, right? Now this shows all the information that's coming from the GPS receiver, which is very important to know before capturing data in the field to see what the receiver is doing and what it's sending. So currently we have an accuracy of just over 1 centimeter. We're going to walk to our current feature. We're going to capture a water valve. So here we are. Now you can see I've already built, I'm going to go ahead and stop it for just 1 second here. I've already built a custom form for this particular map, right? And you can see I've set it up already to have required fields and collapsed groups. We're going to populate this information. We're going to choose the valve type. We're also going to choose the outlet size for this particular valve. You can see these are all required values per how we configured it in the smart form. So we use a similar method like we did before to create this smart form using the Field Maps web application. So we see we have maintenance information. We're going to choose our current date. We're going to choose the field editor. In this case, we're just going to pick from a list. We're going to find my name. And we're going to choose, is there maintenance that's required? No. We're going to take a picture of this particular asset. We're just going to capture the valve cover. Use photo, and then we're going to submit this feature. Now once we're done, in this particular data, we've also added a series of GPS metadata fields to capture specific attributes from the GPS receiver. We're going to see what those values look like now. So let's go ahead and expand our pop-up, and we're going to see we have the receiver name, and all these fields underneath it are populated automatically from the raw GPS measurements from the receiver. So we have that information for QA, QC later on back in the office if you want to see what accuracy we got, what fixed type we had, things of that nature. So now we're going to close that. We're going to select this feature, and we're going to do a similar process like you saw previously with the Park Assets map, where we're going to copy this feature. So we're going to stroll on over to our next water valve. And we're simply going to copy that feature from the previous location to this location. Right? And it's using our current GPS accuracy, which is again a little over 1 centimeter. We're going to update the ID, and we're going to change any other relevant attribute information for this particular feature. So it's the same type of valve. We don't really need to change that. We don't really need to update many things here except for the condition of this feature. We want to repair it. As you can see, we have a hidden set of fields that become visible depending on if it needs maintenance or not. In this case, action needed, and notes become visible. So let's add a note, say the valve is leaking slowly because it needs to be repaired. We're going to take another photo of this valve. And let's go ahead and submit this feature. So again, we're going to take a look at our metadata fields. You can see they're all populated correctly with the values that we want to store. And now what we're going to do is we're going to enable GPS averaging. So we're going to average 15 locations, and we're going to average these in our next water valve that we capture. So we're going to walk on over to our third water valve. We're going to keep this one highlighted because just like we did before, we're going to copy this water valve to the next feature, these attributes to the next water valve. So let's stroll on over to our third water valve. We're going to copy this feature. And what you're going to notice is that our averaging process is going to begin. You can see at the top we have our averaging progress indicator that's counting up for the positions that we have. So we're waiting for 15 positions, and then you can see the graphics for the point cluster on the map, and it all converges to a single point, an averaged point, once it's done. So now we're going to change the relevant attributes for this feature. And this does not need to be maintained. There's no maintenance on this particular feature. So we can go ahead and take a photo. And then we're going to submit this. Now we're going to review the metadata, and the metadata is going to look a bit different. All the metadata that you've seen before is per a single location. Now we have different sets of metadata that gets populated for averaged positions. So you can see as we scroll down, we have receiver name. There's certain fields that are now blank that pertain to a single location. Now we have these fields for average horizontal, average vertical, positions, standard deviation. Those fields now become populated per averaging. So we have specific metadata fields for averaging. So we're going to disable averaging because we no longer need to use that. What we want to do now is we want to search for an existing fire hydrant per its barcode by scanning a barcode like I showed you how to do before. But we're going to search for it rather than enter it in as an attribute. So we want to search for an existing hydrant because we need to update its GPS location. So there's our hydrant way over there, and it's currently incorrectly placed. So now I want to navigate to this feature. Right? We're going to use a mode called compass mode. Right? And this allows us to get a location and a bearing and a distance, if you will, to that particular feature. So you can see there's our location, and in the bottom right corner of the screen, which is the upper right corner of the pop-up display, you can see, and as I speed this up, you'll see that we have the bearing, and we also have the distance as they change as I get closer to that feature. So using my 1 centimeter level of accuracy, we can get pretty precise with where we're at. Now I'm walking to the location of where the hydrant should be, the actual hydrant. So I'm not going to get right to 0 for that because I'm not walking exactly where that feature currently is. So now that I'm there where I want to be, Right now, I simply want to edit this feature and move it to my current location. So simply update this feature and I update any relevant information that I need to. This hydrant needs to be replaced because it's non-functioning. As it's been damaged. We'll take a photo of it. And let's go ahead and submit this. And you can see we have our updated metadata information for this new location. So this should be relevant to its currently updated position, all the new metadata values. And that's pretty much it for the field data collection process. As you can see, we use a high accuracy GPS receiver, which is much more accurate, as you can tell from a previous demo with the park assets, which was over 5 meters, whereas this is a little over 1 centimeter. So we were able to get precisely where we need, specifically for the type of features we were capturing. We also used copy, just like we did before, to speed up the monotonous of doing the same type of features over and over again and just simply changing the related attributes for that new feature. We also demonstrated how averaging works and how you enable that, and you can see the individual point cluster on that particular feature. And we also searched for an existing feature based on a barcode, and we use compass mode to navigate to it. So there's a lot of helpful things that we explained here that assist with the high accuracy data collection workflow. So just a recap, again, just a bit about what we talked about. So initially we use GPS details, right, which is available by tapping on the GPS banner at the very top. It expands and you see the full list of attributes with all the information that is coming from the receiver, right? So you got altitude, you got the fixed type, number of satellites, etc. Right? We also, on the right, illustrated what's called base map overzoom. So we have 1 centimeter of accuracy. So all those points, while we were averaging, were being super clustered very tightly, right? So in order to see that, I had to zoom in very, very close. You can see the base map is very pixelated. So we zoom in beyond the minimum scale range of your base map to allow you to do that in case you wanted to see the differences, the small distances between individual points when you're using such high levels of accuracy. We also discussed metadata. So a little bit more about the metadata. So the GPS metadata fields, again, stores the raw, untransformed GNSS measurements from the GPS receiver for points only. They're very useful for performing further data analysis and for performing QA/QC on the field measurements. And the fields can be created in several different ways. There's a tool in ArcGIS Pro called Add GPS Metadata Fields that will add all these fields automatically. If you create feature services through ArcGIS Online or ArcGIS Enterprise using the built-in templates, there's a checkbox called Capture GPS Receiver Information that will also add these fields. And lastly, we have a GitHub repository called Collector Tools, as these fields were implemented with the Collector application, yet the fields still work for field maps. So even though the repo is called Collector Tools, it's still related to field maps. So you can leverage the tools in that repository as well to help create these fields in your point attribute table. Lastly, we wanted to share some additional resources. These additional resources can be found on the Field Maps resources page at Esri.com. From here you can access discovery paths, help documentation, as well as featured blog articles. Some additional links as well. The first one is a link to the Collector Tools GitHub repository that I mentioned earlier about how you can generate the GNSS metadata fields. Another link is to how to configure a smart form as well as high accuracy data collection. And I also provided this link to the ArcGIS Field Maps migration guide. If you're currently working with Collector, Explorer, or Tracker and you are looking to migrate to Field Maps, this guide can help you with that process. So on behalf of both Colin and myself, we want to thank you for watching this session with us, and we would very much appreciate you providing us with your feedback. Thank you very much. Have a great afternoon.